All right, we are to one of my favorite lessons in geometry right now, and it is the trigonometry part of geometry. Excuse me, and you guys are probably going to be so happy that we are not in school right now, because if you did not watch the video of the song about SOHCAHTOA, you're missing out. First of all, you really do need to watch that. It's pretty catchy, and it really does help you remember these trig ratios, but you're probably going to be happy because literally I would have played that every day until the end of the year, I bet. So you would have either completely loved it or completely hated it, but I guarantee you would not have forgotten it. If you ask anybody about what they remember from last semester, they would probably say the SOHCAHTOA song. And some of them liked it, and there are several different versions, but the one I'm going to be playing in the background is quite possibly my all-time favorite one because it's very catchy. Listen. All right, so we'll stop it there for now. And you're probably wondering, oh my goodness, what is this SOHCAHTOA? So I do have it up top here, if I get to draw. All right, so SOHCAHTOA, it's just a mnemonic device to help you remember sine, cosine, and tangent ratios. The other thing I will say is this always deals with right triangles, and it only deals with right triangles. So we actually, that's what the last two sections of this chapter are, is okay, how do we find out this information with triangles that are not right? So we're going to focus on right triangles today. This is also the lesson that, it's not really warm today while I'm doing this video, but if it is warm, we would have gone outside to find the heights of different objects that we would not be able to measure. So it is a little bit disappointing, but you get to watch the song, so that's at least enough. So, SOHCAHTOA. I'm going to draw a right triangle. And I'll probably end up drawing another one in a second. So here's our right triangle, okay? We know we have one right angle. Now this is where in the song he starts to talk about you need to choose an angle. It doesn't matter which one you choose. Every problem will probably have a different one. But there are only two options. It's either going to be the top angle or it's going to be this bottom angle. Okay, but for now, because I have to choose one, I'm going to choose the top angle. Okay, so we're going to go ahead and label this triangle, which you can see it is here in this key concept box. But if this is the angle I am choosing, the one, there's an opposite side. Okay, it's opposite. It's the one that is opposite of that angle. And we've talked about opposites before, so we're good on that. We need to remember that the hypotenuse is always across from my 90-degree angle. So there's my dashed line, my 90-degree angle. That one faces the hypotenuse. Now there's only one other side, and that's the adjacent side. And you're probably saying, well, there's two sides that are adjacent to this angle, and I agree, because remember, adjacent means beside it. One of those sides is the hypotenuse. So guess what? That one's already taken. So that leaves me with my last one, which is my adjacent side. All right, and I told you I would draw another triangle since it's a little bit smaller. There's my right angle. All right, so now let me get a different color. Oh, there we go. Now if I'm looking down here at this angle, okay, this one down here, guess what? My hypotenuse, that one never changes. That one is always across from that 90-degree angle. But now the side opposite is over here. And the side that's adjacent, meaning it touches that angle, that's down here. So the opposite and adjacent sides depend on the angle in which you're referencing. Okay, that's one of the biggest things about these trig ratios. Okay, so you pick an angle, and then you label what's the hypotenuse, what's the adjacent, what is the opposite side. All right, so with that being said, we have sine, cosine, and tangent. Notice how here, sine, cosine, tangent. The abbreviation is SIN, but we still say sine. This is one reason I'm probably happy, because I don't have to listen to you guys say sin of angle A all the time. It's still the sine. Cos, it's not cos, it is cosine. It's still that whole word, but we abbreviate it. And it's not tan of angle A, it's the tangent of angle A. So even though we use the abbreviations, we still say sine, cosine, and tangent. If you continue your math classes and you take trig and calc, you will look into sine, cosine, and tangent in much greater detail. This is just the geometry part of them to help finding angle measures and side lengths. So, first example, let's go ahead and get started. It says we have to find the sine, cosine, tangent of L, the sine, cosine, tangent of angle N, and then we have to express each ratio as a fraction and a decimal. Oh my goodness. Okay. So we are going to start with L, okay, because that's my first one there. So I'm going to put a line through L, the angle, that way I know which one they're referring to. So I'm also going to write all this out. So I have a sine of L, cosine of L, and tangent of L. Oh my goodness. I'm getting one little step ahead of myself. Well, I'll have both of them up there. Okay. So SOHCAHTOA comes from the SO part, the SOH. So if I'm looking at hypotenuse, opposite, adjacent, notice after my S for sine, my C for cosine, and my T for tangent, it's all O's, A's, and H's. So the fraction, or the ratio, that's what I got, for sine is the opposite over hypotenuse. Okay, opposite over hypotenuse, which is where the SO comes from in the SOHCAHTOA. The CA, which is cosine, A is adjacent, H is hypotenuse, so the cosine's ratio is adjacent over hypotenuse. And last but not least, the TOA, which is our tangent part, that comes from opposite over adjacent. Tangent, opposite, adjacent, that's where the TOA comes from. So SOHCAHTOA, okay? There are videos you can look up of how this name came about, but it's all just little stories to entertain you. But some of them are pretty entertaining. So let's take a look at sine. Remember, I always write SOHCAHTOA off to the side. SOHCAHTOA. So sine is opposite over hypotenuse. And usually we do OPP over HYP. I'm just going to use O and H since limited on space here. So there's my L. Now let's label all of the sides. The one opposite is over here. So that's my 8. Oh, where's my 90? My 90-degree angle is M, so that means the side opposite. That is my hypotenuse, which means 15 is my adjacent side. So now that we have all of our sides labeled, we can find all these ratios actually very quickly. So sine is opposite over hypotenuse. So that leaves me with 8 over 17. Cosine, that's the CA part, so that's adjacent over hypotenuse. So my adjacent side is 15. My hypotenuse is 17. And tangent is the TOA part, so that's opposite over adjacent. So my opposite is 8, and my adjacent is 15. So there's all my ratios as fractions. Done. It did ask for them in decimal form, so let's write all of them out. I'm probably just going to do it for this one. So 0.4706. We should do 4 decimals if possible. 15 divided by 17. It's going to be approximately 0.8824 if I'm rounding. And then 8 divided by 15. That is 0.53 repeating. Okay? So that's all for angle L. I'm going to go erase some of this here because now they want angle N. So let's do angle N. All right, so angle N is up here. Hey, guess what? 17 is always my hypotenuse. The one opposite N, though, is now 15. And the one that's beside it, that's not the hypotenuse, well, that's my adjacent side. So that's 8. So now we have to do the sine of N, the cosine of angle N, and the tangent of angle N. So sine is opposite over hypotenuse. So here's my angle N. Opposite is 15. Hypotenuse is 17. Cosine of N is adjacent over hypotenuse, so that ratio is 8 over 17. And finally, tangent is opposite over adjacent, so that is 15 over 8. And if you look, we do have all these decimals over here. 15 over 17 is that. 8 over 17 is that. 15 over 8 we don't have, so I'll go ahead and do that one. 15 divided by 8. That is approximately 1.875. All right, so take a moment, try the your turn. Hopefully that's not too much information. But the more you practice this, the easier it does get. It's just remembering. And I will tell you, if you still have your Keystone formula sheet that I gave you the very first day, this is all on there for you. Those 3 ratios are on that formula sheet for you. So pause the video, take a moment, try the your turn, then come back and check your ratios. All right, so hopefully when you noticed I made a mistake, I don't even remember what I wrote at first anymore. I think I did the sine of A, sine of B, I don't know what I did, but I fixed it to sine, cosine, tangent. And the second most important thing is that you have to reduce your fractions, okay? Just like you've been taught since you were wee little, first learned about fractions, you have to reduce your fractions. So I reduced all of them for you. All right, for example 2, you're going to need a calculator, so you can, and you don't need anything crazy, you just need like at least a scientific calculator, something that has sine, cosine, tangent on it. You can also use that Calculate 84 app on your iPad, or if you just go to the regular calculator on your iPad, and then use the scientific one if it lets you rotate, or even on your phones, if you hold your phone vertically, you have a regular basic calculator, and then if you tilt it to the side, so turn your screen rotation on, it will turn to a scientific calculator and have sine, cosine, and tangent on there for you. Sometimes though, calculators, you hit the sine, cosine, tangent button first and then type in the angle measure and it gives you your answer. Sometimes you have to type in the angle measure, then hit sine, cosine, or tangent, and it will give you the answer. Unfortunately, I'm not there to help each of you individually with your different calculators, but those are just my hints and tricks. If you have questions, just send me a message on Remind, and I'll be happy to help you. So if you are using the calculator on that Calculate 84 app, because I'm still so accustomed to using graphing calculators, you do need to make sure your mode is on degree. And I should say that for any calculator, because they all have ways to turn it to radian, but you want to make sure that it's on degrees. So if you're using the Calculate 84 app, go to the mode button, which is right beside the second button. The third one down from the top should say radian or degree. You want degree to be highlighted. Once that's done, you are good to go. So to do the tangent of 56, you have to hit the tangent button and then type in 56 and hit enter. It's that easy. We're going to do approximately 4 decimal places. So that's going to be 1.4826. Okay? For cosine, you hit cosine of 89, hit enter, and that is approximately 0.1, I'm sorry, let me back that up, 0.0175. Okay? Pretty straightforward, pretty simple. Just make sure your calculator's in degrees. Take a moment, try those 2 your turns. They're not too bad, just typing in your calculator. All right, so hopefully you got that out of the way. Let's move on to example 3. How can we use this in normal everyday life? So it says a fitness trainer sets the incline on a treadmill to 7 degrees, and you can see the 7-degree angle down here. The walking surface is 5 feet long. Remember, if you're on a treadmill, there you are happy, hair blowing in the wind. You are walking up that treadmill, okay? On that incline, like you're walking up a mountain. Approximately how many inches, I saw feet there and inches there, so that's going to be pretty big, did the trainer raise the end of the treadmill from the floor? So that's why we're trying to find y. So it's a 7% incline, but what does that equate to in inches? Like how high am I actually walking? So 2 things here. We can go ahead, I'm going to figure it out in feet, and then I'm going to change that to inches. That way my numbers are just smaller until the end. So let's go ahead and look at this. If this is our angle, maybe I should erase my person. That way it's not distracting you. Because I know it's such a good drawing. If this is my 7-degree angle, that must make y is my opposite side. The bottom is my adjacent side. And that 5 feet, the ramp part that we're walking on, that's my hypotenuse because it's across from my 90-degree angle. So now we don't have to find sine, cosine, and tangent. We just have to find the one that we need to use the most. So I'm trying to find y, which is the opposite, and I know the hypotenuse. I don't know the adjacent, so that would sort of be silly since I don't know the opposite, I don't know the adjacent. I don't want to use those 2. So I'm going to use the trig function that in this case uses opposite and hypotenuse. So if I write SOHCAHTOA up here, opposite and hypotenuse, well, that appears to be sine. So I'm going to do the sine of my angle, in this case we'll call it A, equals opposite over hypotenuse. So the sine of our angle, in this case we know that's 7 degrees. And that is equal to the opposite, which is y, over the hypotenuse, which is 5. So now I have to go through. Don't let the fact that it says sine of 7 bother you. That is just a number. If you want to, you can type in the sine of 7, get the decimal, and write that decimal value in there. But I am going to encourage you to, if you do that, you have to do at least 4 decimal places. Don't give me 1 because your answer is going to be really far off. Okay? But I'm going to try to encourage you to leave that sine of 7 in until the very last step. So to get y by itself, because it's in the numerator, I have to multiply both sides by 5. So my 5's cancel, and we get y is equal to 5 times the sine of 7. And now is the time where you can type that into your calculator to get a more realistic answer. So type it in just the way it is. 5, then the sine button, and then the number 7. Close your parenthesis if you wish. Hit enter, and we get 0.6093, okay? If we're keeping it to 4 decimal places. Now we need to remember that is in feet. So that shows me that's just a little over half a foot, because half a foot would be 0.5, but they wanted it in inches. So about how many inches is that? So I'm going to take that value, 0.6093, and multiply that by 12, because there's 12 inches in a foot, and that gives us approximately 7.3 inches. So if you were at a 7% incline for this problem, with the length of the ramp, that's approximately a 7.3 inch raise off the ground, okay? So take a moment, try the your turn, and then we'll come back and double check it. All right, so hopefully you were able to do that one and get approximately 15.1 inches. So we are going to move on to the very last example. That is example 4. So it says, find the measure of angle X in the right triangle XYZ when we have those given coordinates. All right, so the only way we can find angle measures is if we know all of the side lengths. So you betcha, you guessed it. We either have to use distance formula or Pythagorean theorem to find each of these lengths. But I'm going to go ahead, and if I can read my handwriting here, save us some time, that this one ends up being, I need a color that will stand out, the square root of 32. This one over here is the square root of 50. Because what I just did Pythagorean theorem, so that's 7 units, so that squared is 49, that one's 1, so square root of 49 plus 1 is square root of 50. And y to z is the square root of 18. All right, and they want the measure of angle x, so that's this one here. Now this is where you have some choice. Since we know all three sides, you are able to use any of the ratios. And actually, I might do each of the ratios. That way you can see that we do get the same answer. So let's start with sine. So I'm going to do the sine of x. Then I'm going to do the cosine of x. And sorry, sometimes I put the parentheses there and sometimes I don't. I'm going to wait for this to cooperate with me. Here we go. I need a little more room. Cosine of x, and then we'll do the tangent, just so you can see it doesn't matter. So, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So, the sine of x. The opposite is the square root of 18 over the hypotenuse, which is 50. Sorry, square root of 50. All right, and now I'm going to show you how to solve this. So we want to get x by itself. So just like when we're solving equations, to undo an operation, we have to do the opposite. Well, the opposite of sine is sine inverse. So that's sine with a little -1. And what happens is that those two things cancel. But remember, what we do to one side, we have to do to the other side. So we have to write the sine inverse of the square root of 18 divided by the square root of 50. So if you look at your calculator, especially if you use that Calculate 84 app, sorry, I'm not sure why that keeps moving, the sine inverse button is the same button as sine, but you have to hit second sine. So all you have to do to figure this out is do it in the calculator. Hit second sine and then type in the square root of 18 divided by the square root of 50. And when you do that, you get approximately, so let me erase my equals and put approximately, because we are rounding, 36.87. Now this is an angle measure. Oh my goodness. So that is in degrees. Okay, I'm going to do the same thing for cosine now. I'm going to do it in a different color so it's a little bit easier. So we're going to do the cosine of x, and now this is the adjacent side. So square root of 32 divided by hypotenuse, square root of 50, and x is going to equal the cosine inverse of the square root of 32 over the square root of 50. And x is approximately, let's type this in, so cosine inverse, square root of 32 divided by square root of 50. I will say when you type in the square roots, don't forget to hit the right arrow over. Like I wasn't even touching my iPad that time. The right arrow over, so that way you don't keep putting things under one great big radical. And we get 36.87. Again, exactly the same. Just in case you don't believe me, we're going to go ahead and do the tangent. And because you don't have a year turn, so why not? So we're going to do the tangent of x is equal to, now, opposite, which is square root of 18 over the adjacent, which is square root of 32, which means x is going to equal the tangent inverse of the square root of 18 over the square root of 32. Now type that in the calculator. Second tangent, square root of 18, hit my right arrow button, divided by the square root of 32, right arrow over, close parenthesis. When you know it, it's amazing. We get 36.87 degrees again. So I just wanted to show you that it really doesn't matter what trig function you use, you get the same answer. So for this problem, please remember, you do not have to do all three. You pick one of them. I just did 3 to show you that it doesn't matter which one you choose, you get the same answer. All right, so I know that's really long, but let's let this Sokotoa song take us out.
Sine, opposite hypotenuse sine, opposite hypotenuse sine, opposite hypotenuse cosine, adjacent hypotenuse cosine, adjacent hypotenuse cosine, adjacent hypotenuse tangent, opposite adjacent tangent, opposite adjacent tangent, opposite adjacent. The long sides of hypotenuse and the other 2 sides depend on which angle you're focusing on. Pick one angle and look, there's one side that's the opposite. You can clearly see that there's also an adjacent.